Okay, so we have another difference of squares here. The very first thing I'm going to do here is, you can tell by, if we know this is difference of squares, our two terms in the binomial are a little more complex than we're used to working with. So I'll very quickly say, hey, let x equal 4h minus 2, and let y equal 3z. Okay? I can put them in brackets or not, it doesn't matter. What does that do? I'm going to put 3 horizontal lines means an equivalent statement. Now that we have this let statement in here, I can technically say, well, this is just x squared minus y squared. This is a very simple, what's the term? Difference of squares. Now, I could use decomposition to do this. My downside is usually with decomposition, we're looking for a factor at the end here. So I've kind of gone about this, because it's a variable, I lied when we were going to use the decomposition into this. I'm going to show decomposition and how it relates, and then we'll solve this specific one. Let's say we're doing a difference of squares that's at x squared again, but in this case, it was something like subtract, what's an easy one? 36, okay? This is very close to a trinomial. You could make the argument, so I'm going to draw a line here just so we know that this is a little bit different when we go back to our note. There's my line, okay? Just so I know that a little different here, okay? Actually, I should have done it here. And delete that other line. There we go. We have this question here. I could rewrite this as a trinomial that looks like this. X squared plus 0x minus 36, okay? This is no longer a binomial, and with difference of squares, we deal with binomials. There's 1, 2 terms. That just bi means 2, like a bicycle. Here we have a trinomial, like a tricycle. There are 3 terms, okay? In decomposition, we know we're looking for 2 numbers that multiply to equal whatever, a times c is. In this case, it's 1 times negative 36, which is just negative 36. Those same 2 terms are going to add up to our b value, which happens to be 0. Now, what's neat about difference of squares is we can very quickly realize, hey, I'm going to use, if it's got to be 0, that means I got to have the same value added to itself, just one of them has to be negative. Okay, and that actually works out for the multiplication. Negative 6 times positive 6 gives us negative 36. So that works out great. So if I was to decompose these two things now, I'd end up with x squared, and then I'd have negative 6x plus 6x minus 36. We do a little factor by grouping. We look at the first pair. Hey, what can I factor out of the first pair? Oh, I can take out an x. That will be my common factor. And in my second pair, I can take out the number 6. Okay? When we go to rewrite this all, okay, the x is our common factor from the group. When we divide x squared divided by x, we're left with x. Negative 6x divided x is negative 6. And over, whoops, sorry, that was the wrong value. And our common factor here was positive 6. So positive 6 comes out. 6x divided 6 is just x. And negative 36 divided 6 is negative 6. We do our factor by grouping again. If we're familiar with it, we know we end up with x minus 6. And then whatever's left over is our x plus 6. So in this case, we use decomposition to solve a normal difference of squares. Now in this scenario here, I'm going to have to add an extra page here, and we'll jump back and forth as we go through it. We're back to here, x minus y. So we do want to use that original finding the square root of the first term, finding the square root of the second term to solve, okay? So I went on a bit of a tangent to show you that we could use decomposition when we have a constant or a numeric value as our last term. In this case, we have variables, so we kind of use that factoring strategy to help us out. Square root of x squared is technically plus or minus x, and this would be plus or minus y, but we only need the positive values, or the absolute values, you could argue, of each. We'll put the x as the first term, the y is the second term, and I have plus and minus. But not done, like we said before. 4h minus 2 is equal to x, so let's write that in. 4h minus 2 is equal to x, and 3z equals y. So we're going to substitute those values back in. x now becomes 4h minus 2 plus, and y, maybe we'll do it in, well, we'll do it in red to show substitution, is 3z. And that's the first set of brackets. Second set of brackets, same idea. 4h minus 2 plus 3z. And we just do a little simplification now. So we're collecting like terms. This plus disappears. It says an h, a constant, and a z. None of these are actually like terms. So when I go to write it out, I'm actually left with 4h plus 3z minus 2. So like a trinomial here in the bracket. And then again, 4h plus 3z. Oh, that should have been a minus. I knew something was off there. Oh, that should be subtraction. That should be subtraction. That means this should be subtraction. Minus 2. You'll notice I kind of took this term and put it in the middle here. It's just common when we write out a polynomial, we start with the variable of the highest power. And technically, these are two variables with the same power, the power of 1. So we tend to just write them in alphabetical order. Like you'll notice if you ever have like an x, a y, and a z, it tends to be x is farthest to the left, then y, then z. In this case, h comes before z in the alphabet, so we wrote h, z. And then if there's no variable, that's the constant. That's the last value you could say. Okay.